Welcome to another video in our Coding with Arduino for Young Innovators. In the previous class, we built our first project which turned an LED on and off using a few electronic components. In this class, we are going to build our second project which is similar to the first one, but this time we are going to control the LED using coding and Arduino. So let's get started. To build our second project using Arduino, we need the following materials: a computer, an Arduino board, a resistor, a light emitting diode, also known as LED, a breadboard, and some jumper wires. Since this is our first time using Arduino, we need to set up our computer so that we can use it to write Arduino programs. Another word for coding is programming. So we can say write a code or write a program. Both mean almost the same thing. Because we are learning coding with Arduino, you may sometimes hear me use terms such as coding, programming, Arduino programming, or coding with Arduino. They all refer to the process of writing instructions that tell the Arduino what to do. To set up your computer for Arduino coding, you need to connect the computer to the internet. Then you will download and install the Arduino software called the Arduino IDE. IDE means Integrated Development Environment. This is the software that allows us to write, verify, and upload our code to the Arduino board. With our computer connected to the internet, the first step is to open a browser and type arduino.cc. Once it opens, you scroll down to where you will download the Arduino IDE. Select the appropriate file for your computer and then click download. Choose a location on your computer where the file will be downloaded. Once it is done downloading, click here to navigate to where the file is downloaded. Now here is the downloaded file. So double-click it to start installation. Click I agree. Click Next. Click I agree once again. Here you can click Browse to choose a location where the file will be installed. And when you are done choosing, you click Install. Now the installation process has begun, so you will allow it to finish installation. This might take some time. At this moment, the installation process has completed. We can click Finish to finalize the installation. And once I click Finish, the Arduino IDE will open for me to start using it to write my Arduino code. And now you can see that our Arduino IDE is open for us to use it to write our Arduino code. Once the Arduino IDE is open, if you are connected to the internet, it will prompt you to install updates if there is any updates available. So at this point, you can decide to either install all the updates or install updates manually or install the updates later. Whatever you want to do at this moment, you can do it. But we don't want to install any updates now, so I will cancel the prompt. Now that we have downloaded and installed the Arduino IDE, The next step is to connect our Arduino board to the computer. This is the Arduino board we will be using in this program. Please note that there are many Arduino boards on the market and all of them can be used for this project. But the particular Arduino board we will be using in this program is the Arduino UNO R3. This is the Arduino UNO R3. I will connect it to the computer, and to do that, I will use a USB cable. This is the type of USB cable that I will use, the type A to B USB cable. This is type A and this is type B. To connect the Arduino board to the computer, I will connect the type B of the USB to the Arduino USB port, and then I will bring my computer close and connect the type A of the USB to the USB port of my computer. And once I've done that, you can see that my Arduino board is showing that it is now on. The green LED is on. If I unplug the USB cable, it will go off, and if I plug it, it will come on. So our Arduino board is now connected to our computer. Now that I have connected the Arduino board to the computer, let's go back to the Arduino IDE and set it up so that it can communicate with the Arduino board. Now you can see that our Arduino IDE is open. To set up the Arduino IDE so that it can communicate with the Arduino board, I will click Tools and then I will click Board. You can see that it is already on Arduino UNO. Then I will click Arduino AVR boards and then I will select Arduino UNO. So that is the first step. Then the next step is to make sure that the appropriate COM port is selected. So I will click Tools again and then I will come to Ports and click it. And you can see that COM port 6 is selected and it is where the Arduino UNO is connected. So this shows that everything is now set for us to write our code, verify it, upload it to the Arduino, and have our project up and running. So let me paste the Arduino code for our project on the Arduino IDE and explain what the code will do. This is the code for our project. If you look at this code, the first line of the code is what we call a comment. In Arduino programming, when we have a line of code that has 2 forward slashes coming before a statement, that statement does not have anything to do with the code. That statement is just a comment. So here we have 2 forward slashes that come before a statement. Hence, it means that this statement does not contribute anything to our code. Rather, it is just a comment. Here also we have another statement that comes after 2 forward slashes. This too is a comment. We have it here, we have it here, 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 and here. So all these statements that come before 2 forward slashes are comments. Now the first comment says blink LED connected to digital pin 2. So what this means is that this code is a code that will blink an LED that is connected to digital pin 2 of the Arduino board. If you look at our Arduino board, you can see that we have digital pins. So we have about 14 digital pins from pin 0 to pin 13. We also have analog pins. We have about 6 analog pins from analog A0 here to A5. So we have digital pins and analog pins. So our code is a code that will blink an LED that is connected to pin 2 of this Arduino board. And here is pin 2 of the Arduino board. Now, the next comment we have there states that the code inside this function runs once. So what this means is that the code inside this void setup function, that is the code inside these 2 curly braces, this is the opening brace and the closing brace. So the code inside this brace runs once, and that code is a code we use to set pin 2 of the Arduino board as an output. You can see here pin mode 2 output. Now we have another comment that says the code inside this function runs forever. So it means that the code inside this void loop runs forever. That is, the code inside these 2 opening and closing braces, this opening and closing curly braces, run forever as long as power is connected to the Arduino board. That means this is the code that will run forever in the Arduino, while this code here will run just once when we upload the code to the Arduino board. So what does this code mean? Well, the comment here says that this code turns on the LED. So it says digital write pin 2 high. So it means that the LED that we connect to this pin 2 will come on. And then the second line of code says delay 1000. So what this means is that once the LED that is connected to pin 2 of the Arduino board comes on, it will stay on for 1000 milliseconds. This 1000 here is in milliseconds. So the LED will stay on for 1000 milliseconds, and 1000 milliseconds is equal to 1 second. And then after that, we have digital write pin 2 low. So what this means is that at this point, once this code goes into operation, the LED will go off. So the comment here says turn LED off, and once the LED is turned off, this code will go into action. It says delay 1000. It means that the LED should stay off for 1000 milliseconds, which is 1 second. And because this code is inside the void loop function, it means that the moment we get to this end of the code will again start from here to run again. It will go down step by step and then go back again. So this is the void loop function code. It will run forever until power is disconnected from the Arduino. So from what I explained, it means that this code turns on the LED that is connected to pin 2 of the Arduino, and this code makes that LED to stay on for 1 second, while this code turns it off, and this code makes it to stay off for another 1 second. So we have the LED on for 1 second, off for 1 second, on for 1 second, off for 1 second. So that is what this code will do. Now, for our LED to blink as we want it to blink, as our code wants it to blink, we will have to connect our LED to the Arduino board. To do that, we will use this circuit diagram. On the circuit, you can see that one leg of the resistor is connected to pin 2 of the Arduino board, and the other leg of the resistor is connected to the positive leg of the LED, and the negative leg of the LED is connected to the ground pin of the Arduino board. The ground pin of the Arduino board is the same thing as the negative terminal of the battery, which is where electricity will return to make a complete circuit. So, having shown the circuit diagram, let us now connect the physical components and realize our circuit. To help us with the circuit connection, here I have a breadboard and some jumper wires. The first thing to connect is a jumper wire to pin 2 of the Arduino board. So I'm using this red jumper wire to connect to pin 2 of the Arduino board. This is pin 2 of the Arduino board, and I've connected the jumper wire to it. Then I will connect the other leg of the jumper wire to any point on the breadboard, as you can see here. Now the next thing is to connect my resistor. So I will connect my resistor, one leg of my resistor, to this pin of the jumper wire. So I will connect it here, and then I will connect the other leg of the resistor to any point on the breadboard, as you can see. Now the next thing is to connect my LED. So I'll connect the positive leg of the LED to this leg of the resistor, and then the other leg of the LED I can connect any point on the breadboard. So here I have the positive leg of the LED connected to this leg of the resistor, and this is the negative leg of the LED. So I will connect this jumper wire to it, and then I will connect that jumper wire to the ground pin of the Arduino board. On the Arduino board, we have about 3 ground pins. This is one of the ground pins of the Arduino board. It is abbreviated as GND, and here we also have other ground pins of the Arduino board. Okay, so we have other ground pins, about 2 ground pins of the Arduino board here and here. So I can connect the other jumper wire here. So we have our circuit complete. So here we have the jumper wire connected to pin 2 of the Arduino board, as you can see here, and that jumper wire is connected to one leg of the resistor here, and the other leg of the resistor is connected to the positive leg of the LED here, and then the negative leg of the LED is connected to a jumper wire, which is then connected back to the ground pin of the Arduino, and our circuit is complete. What we have here is what we have on the circuit diagram. So, having made our circuit connection, the next thing to do is to upload the Arduino code to the Arduino board. Now, you should also know that another name for Arduino code is sketch. So, to upload this sketch to our Arduino board, we can first come here to verify the code, or we can click upload to upload the code. However, the moment we click upload, the code will first verify before uploading. So I will click upload, and you can see here it says compiling. So compiling is something as verifying, and when it is done compiling, is uploading. After uploading, it is done uploading, and you can see that the LED is blinking. It comes on and stays on for 1 second, and then it goes off and stays off for 1 second, and the process continues as long as power is connected to the Arduino board. To stop this from happening, I will disconnect the Arduino board from the computer. So once I disconnect the Arduino from the computer, the LED goes off. And if I plug back the Arduino to the computer, the LED comes on again and it keeps blinking. Now, one good thing about coding is that we can change the time the LED stays on and the time it stays off. We can change the rate of blinking of the LED. To do that, I will go to the code and change the delay time. So let's change the delay time to 500 to make it blink faster. So I will change the on time to be 500 and change the off time to 500. Then I will upload the code, and you can see it is compiling, and after compiling it will upload. Compiling, uploading, and it is done uploading. You can see that the blinking frequency or the blinking rate has increased. Now we can increase it further. So let me change it to 100. Let me change the delay time to 100, and we'll observe what happens. So I'll upload now. It's compiling. After compiling, it will start uploading. It is uploading and it is done uploading. Now you can see that the LED is blinking faster. We have been able to use coding to change the blinking rate of the LED. This is the beauty of coding. With just changing few lines of codes or changing few things in the code, you can effect a change in the behavior of the circuit. That is the beauty of coding. So this is our second project, a project where we use Arduino and coding to control the behavior of a light emitting diode. This time we didn't use a switch as we did in the previous class. Rather, we used coding and Arduino to realize the results. And that is the beauty of coding with Arduino. Alright, in this class, we learned how to set up our computer for Arduino programming by downloading and installing the Arduino Integrated Development Environment, that is, the Arduino IDE. We connected the Arduino board to the computer and configured the Arduino IDE so that it could communicate with the board. We also learned about a simple Arduino code, including the setup and the loop functions. And we wrote our first Arduino code to control an LED connected to pin 2 of the Arduino board. We built the circuits on a breadboard, uploaded the code to the Arduino board, and observed the LED blinking on and off automatically. Finally, we observed that by changing the delay value in the code, we can change how fast and how slow the LED blinks. In the next class, we will continue learning how to use coding and Arduino to build even more exciting electronics projects. I am Instructor Izu, and see you in the next class. Bye.